A Chinese rover quietly made a discovery beneath the Martian sands. 76 mysterious underground layers, each one rewriting what we thought we knew about Mars. For decades, we believed Mars was a cold, dead desert. But China's first interplanetary mission, Tianwen-1, changed the story completely. Beneath the dusty plains, scientists detected signs of ancient floods, buried ice, and salt-rich crusts. Evidence that liquid water may have survived on Mars far longer than we ever imagined. And if water stayed that long, what else might have stayed with it? It began on July 23, 2020, when China launched Tianwen-1, its first fully independent mission to Mars. A single spacecraft carrying an orbiter, lander, and rover, all built domestically. No NASA help, no borrowed blueprints. After a 7-month cruise through deep space, Tianwen-1 entered orbit around Mars in February 2021. 3 months later, on May 14, 2021, the lander touched down in Utopia Planitia, the same vast plane where NASA's Viking 2 landed 45 years earlier. Riding aboard was the Zhurong rover, named after the Chinese god of fire. Standing at 1.85 meters tall and weighing 240 kilograms, it became the first non-NASA rover in history to operate successfully on Mars. It was only designed to survive 90 Martian days. Instead, it worked for over a full year, traveling nearly 2 kilometers before going into hibernation in 2022 as winter darkness and heavy dust choked its solar panels. A modest mission, but what it found beneath the surface shook the scientific world. Zhurong carried a ground-penetrating radar that scanned up to 35 meters deep, and right below the dust, it revealed something never seen before on Mars. 76 distinct horizontal layers. Each layer marked a dramatic shift in Mars's environment, a floodplain here, a frozen sheet of ice there, or massive waves of dust dumped by ancient storms. Scientists at the Chinese Academy of Sciences concluded these layers record cyclical flooding, where buried ice melted, flowed, and refroze over hundreds of thousands of years. Its instruments also detected hydrated minerals and salts, the kind that only form in the presence of water. Thin, salty crusts that trap moisture, suggesting liquid brines may have existed just below the surface even in Mars's freezing modern climate. And the dunes around the rover revealed another surprise. Traces of recent glacial activity. Cracked surfaces, smooth dunes, signs that liquid water, or mushy ice, may have been present as recently as 400,000 years ago. That's not ancient in planetary terms. Back then, early humans were already walking on Earth. For decades, scientists thought Mars lost its water billions of years ago. But Zhurong changed that timeline. If Mars had water so recently, then the window for potential life stayed open much longer than we ever dared hope. Maybe life on Mars didn't die out billions of years ago. Maybe it survived just beneath the dust, hidden, waiting. Nearly half a century before Zhurong landed, humanity first asked the big question: is there life on Mars? In 1976, NASA's Viking 1 and Viking 2 landed on the Red Planet, each carrying the first biology labs ever sent into space. Their mission? Test the soil and see if anything inside was alive. Sensors lit up, reactions happened, but the results split the scientific community in two. Some believed Viking had found life, others insisted it was just reactive chemicals, specifically perchlorates, salts now known to mimic the signature of biology. The debate still continues. And here's the twist. Mars wasn't always a frozen wasteland. Its climate swings wildly, controlled by Milankovitch cycles, changes in the planet's orbit and tilt that transform its weather over time. Mars feels these shifts even more dramatically than Earth. 1. Orbital eccentricity. Every 100,000 years, Mars's orbit stretches and squeezes, causing intense warming cycles that melt buried ice, leaving behind the very layers Zhurong detected. 2. Axial tilt, or obliquity. Without a stabilizing large moon, Mars's tilt swings massively from 15 to 35 degrees over hundreds of thousands of years. When it tilts too far, the poles melt and ice migrates toward the equator. When it straightens again, everything freezes solid. Zhurong's radar data lines up perfectly with these icy migrations. 3. Precession,
the slow wobble of a spinning top, shifts which hemisphere gets stronger sunlight, redistributing water and dust planet-wide. Together, these orbital gears act as a cosmic climate clock. Each layer in the Martian crust is a tick, a chapter of Mars's watery heartbeat. Those 76 layers aren't random. They are a planet's memory, written in ice. And now the next chapter of China's Mars story is already underway. Tianwen 3 Sample Return Mission, launching in 2028, returning 2031. 2 Long March 5 rockets, a lander, an ascent vehicle, a return capsule. Target landing sites include Utopia Planitia, where Zhurong made its discoveries, and Chryspanitia, home to ancient deltas and lake beds. These are prime hunting grounds for biosignatures, chemical traces of ancient life. Tianwen 3 will drill, collect samples, and fire them into orbit, where they'll be captured and flown back to Earth. And China promises international access to the samples, not locked away behind closed doors. If they succeed, China could beat NASA's delayed sample return mission and become the first nation to bring Mars to Earth. Inside those tiny tubes, we might find organic molecules, fossils of ancient microbes, or the first undeniable sign that life once lived on Mars. One discovery, and history changes forever. While Zhurong sleeps beneath the Martian dust, China is already preparing humans for the journey. In Gansu Desert sits Mars Base 1, a $61 million analog habitat with pressurized modules, greenhouses, and simulated dust storms. Further west, Mars Camp in Shanghai is even more rugged, built for survival training, engineering tests, and preparing future explorers for 200 million kilometers of isolation. This is only step 1. China plans 5 human Mars missions: 2033, 2035, 2037, 2041, and 2043. Early missions will test life support and fuel production. Later ones aim for permanent settlements. Nuclear-powered propulsion is already in development, promising to cut travel time in half while supplying constant energy in deep space. And beyond rockets, concepts like a space elevator using carbon nanotubes, a future where cargo climbs into space without a single drop of rocket fuel. Ambition versus speed. China, strategic, state-driven, long-term. SpaceX, rapid innovation, trial by fire, a million-person city vision. Different paths, same finish line. Whoever solves the problem of mass transport to Mars wins the next century of space exploration. By 2031, the first Martian samples will return to Earth. Maybe inside them, the answer to humanity's oldest question: are we alone? If a single microfossil is found, that moment will divide human history into before and after. And as China races to bring Mars home, it is also preparing to go there itself. So we must ask, what happens if China becomes the first nation to colonize Mars? Subscribe for the next chapter, and tell us in the comments, do you believe life is still hiding beneath the Martian surface?